Hello, greetings to you, my dear students. Today we are going to see one very interesting topic, my dear students. Yes, it's graphical transformation part 8, my dear students. Already I have taught 7 lectures for this, my dear students. You might think, so what is there in graphical transformation? Go and check those lectures, my dear students. It will be very awesome lectures for you. You can enjoy a lot, you can learn a lot, and those things will be very useful for your JE level exams, my dear students, also for your board exams also, my dear students. Now let's go into the topic, my dear students. So this is the divisions of functions, my dear students. Already I have taught you polynomial functions. In polynomial functions I have done 3 lectures, in rational functions 2 lectures, irrational functions 2 lectures, and piecewise function it will be 2 lectures, my dear students. Now I am going to cover this modulus function and signum function. In next lecture I will cover these 3, my dear students, and I also greatest integer function, fractional part, very important, my dear students. If you haven't watched those lectures, please go and watch it. It's very useful for you. Okay, in JE basic mathematics they have asked so many questions from greatest integer function. Okay, my dear students, let's go into the topic. Let's see what is piecewise functions are. First, you all have to know what is piecewise function. Piecewise function is nothing, my dear students. The function which can be cut into so many pieces, then that function is called piecewise function. That's all, my dear students. Okay, so what sir you are saying? You are saying like a cake. Yes, you can, you are cutting the cake, right? Like that you are cutting into so many pieces. Likewise, if the function can be divided into so many sequence of intervals, then that function is a piecewise function, my dear students. That's what they also have defined, function that is defined on a sequence of intervals. For every sequence of intervals, it will give some different values, my dear students. It won't give the same value for the over the sequence of intervals. It will, so many sequence will be there. For each sequence of interval, it gives different values. So only that functions are called as piecewise functions, my dear students. Okay, in that piecewise functions, these 5 functions are like very important, my dear students. These 5 functions are there. These 5 functions also is there in your JE level syllabus, my dear students. Least integer function, that is not there, but just learn it, my dear students. It's just the opposite of greatest integer function, but he is very important. Okay, my dear students, in this today lecture we are going to see absolute value function or modulus function, my dear students. We denote this modulus function in symbol. We want some representation, right, my dear students? That is modulus x. This is what the modulus function symbol, my dear students, mod x. In between the parallel of 2 lines, there is one function. Whatever function it can be, my dear students, not only x sin x, it can be tan x, whatever. It will act as the modulus function. A modulus function means what, my dear students? Already I have uploaded one video. If you want to learn so many things about modulus function, please go and check that function, my dear students. The basic thing is modulus function, it always gives the positive value, my dear students. Why it is always giving the positive value, my dear students? Because that function is also called as distance function. For calculating distance, we use, my dear students, for like, sir, it's a minus 10 kilometers from here. Even for digging the well or doing bore well for water purpose, on the time also we used to measure with feet only, my dear students. We don't tell like, sir, it's going under the earth, so I am going to say it's minus 5 kilometers, sir, minus 500 feet, sir. No, my dear students. So whenever it comes to distance, wherever you go, if you go to moon, Saturn, wherever, Mars, wherever you are going, we will measure the distance with positive values only, my dear students. With natural numbers only we do. In the same way, modulus function is also called as distance function. So whether it goes to negative side or positive side, it doesn't matter. The distance from the origin, which is going to be minus 5, means 5 units. So only they are saying this function as the positive function, distance function, my dear students. There are so many names it has. Now we are going to see how this graph we are going to do, my dear students. After that graph, and we are going to see the entire research. The domain, range, symmetric, everything we will see, my dear students. Okay. So the modulus x, the graph is going to be very simple, my dear students. 0, 1, 2, 3, -1, -2, -3. So 1, 2, -1, -2. Okay, my dear students. Now, my dear students, for 0, we'll take 0. Before going into the always graph, my dear students, try to find the domain. Domain is very important. Even range, you can find it by plotting the graph, my dear students, but domain is very important. First, you have to see, for any values, will this function give me any undefined values? That is the core thing you have to see, my dear students. So here you are seeing it's a modulus x. Mod x means whatever negative, it is going to be positive. Whatever positive numbers I am going to give, again it is positive only. So it can take any numbers, it can take any r. Here it is not mentioned like you have to take only the integers, not like that, my dear students. Any irrational number, rational numbers, integers, positive integer, negative integer, real numbers, whatever you want you can take. That's what he is saying. So the domain is R, my dear students. So we are starting with 0, my dear students. Then for 1 also, it will give me 1. For -1 also, it will give me 1, my dear students. That is the speciality of this function. So for 2 also, it will give me 2. For -2 also, it will give me 2, my dear students. Now, if you see only on first quadrant, my dear students, this function looks like the identity function. In identity function also, it comes straight, it goes down, because for -1 it will take -1. But here what will happen, it's like a reflection, my dear students, like the ray is coming and it reflected to this side and this goes like this, my dear students. Okay, so the modulus function means wherever it goes negative, it will just convert, because if it is an identity function, it goes down. The same rule will be act in every function, my dear students. Whatever function you take, and if you apply, if that function is an odd function, I am saying, my dear students, if it is an like even function, already it will be in upward only, so no problem. But whenever the function is odd function, whenever it goes down, just it will bend here and it will go like this, my dear students. For everywhere, I'll teach you when it comes to sin x function, cos x function. On the time, I'll tell you how it actually acts, my dear students. These are going to be very interesting and crazy, my dear students. So now, my dear students, now we are going to see all the research. So it is going to be very easy for you, my dear students. Already we have find the domain, which is what, my dear students? It is R. And what is range, my dear students? By this graph you can easily say from 0 to upward only it's going. So all the positive values, which means R plus. But R plus is alone, my dear students? No. Why? Because 0 is included. So R plus union 0, or how we can write, my dear students? 0, infinite. Like this also we can write, my dear students. Then symmetric. Symmetric about, my dear students? Y-axis. So if it is symmetric about y-axis, then how it will be, my dear students? If it is symmetric about y-axis, then it is an even function. You have to be very careful, my dear students. Okay, if it is symmetric about y-axis, that function is an even function. If it is symmetric about opposite quadrants or origin, then that function is an odd function. If you have a doubt, please check it, my dear students. Otherwise, go and watch the first lecture. In that lecture only I explained in brief, so only it took me so much time, my dear students. I have explained nearly for half an hour. That is also for identity function. Then periodic, my dear students, it is not a periodic function. Why? Because it is not again going to give me the same value again and again, my dear students. For 0 it is 0, that's all. For every value it will give me the some other values only, not the same 0. It won't repeat again, so that it is not a periodic function, my dear students. Okay. Now one-to-one function, my dear students, is it one-to-one function? No, my dear students. Why? Because if I draw the line, horizontal line, it is just strikes me here and here at two places, my dear students. If my graph strikes at two places, then that function is not a identity function. Okay, sorry my dear students. So that function is not an one-to-one function. So that it is not a one-to-one function, it have to strike at only one place, my dear students. As well as whether it is onto function or not. So onto is always like the based upon the codomain, my dear students. If the codomain are same like the range, then it is onto function, my dear students. If maybe I take R plus or R like that, if I take, then my function is not onto. Okay, my dear students. Then bijective, my dear students, whatever it is, it won't be bijective whether it onto comes or not, because one-to-one strictly no, my dear students. One-to-one never, it won't come. Okay. Then, my dear students, increasing, decreasing, interval wise it will change, my dear students. When it comes to calculus, on the time I will explain you clearly. Okay. Then derivative, here it matters a lot, my dear students. Derivative in the sense differentiable everywhere. No, my dear students, because it is not differentiable at origin. I said right, the graph have to be smooth and continuous. If there is any bend like this, like V, then that function is not differentiable at that particular point. Not the entire point, my dear students. At that particular point it is not differentiable. So here it is not differentiable at origin alone. So differentiable everywhere except at 0. Okay, my dear students. So we have finished the modulus function research, my dear students. Now we are going into the topic, what, my dear students? Signum function. That is going to be very easy as well as crazy, my dear students. So signum function, graph of signum function, y is equals to, this is the symbol for this function, my dear students. Before entering into this graph, you have to know what is signum function. Some of you might have known, some of you may not know, my dear students. So for them, let me explain graph of signum function, which means y is equals to SGN of x is equals to, my dear students, this function have three values, my dear students. First, let me tell the function y is equals to mod x divided by x, my dear students, or x divided by mod x. This is the function, my dear students. In this function, entire domain is there, my dear students. You can apply whatever the values you want, but the range for this function is only three values, my dear students. Only three independent values. See here, mod x by x, x by mod x. Okay, this is the function, but why is the range is only 3? See, my dear students, for r plus my x value, if my x belongs to r plus, then my value is always 1, my dear students. If you want, you can check it, my dear students. Please check. So 1 by 1. So mod x means don't care, my dear students. For r plus, it is going to give me the same value. So for me, it is not going to change, make any kind of change. So x by x it will become. So it will be 1 by 1. 100 means 100 by 100. 1000 means 1000 by 1000. 1 lakh by 1 lakh. 1 crore by 1 crore. 1. That's all, my dear students. Then 0. X belongs to 0 means if it is x is equals to 0, this value gives 0. No problem at all. 0 by 0, 0, my dear students. Actually, that is undefined. Here they are taking as 0. It gives 0 for this function, my dear students. And then or negative, x belongs to or negative, my dear students. When it comes to negative, for every value it gives -1. Okay, so x here, if you replace with -5, my dear students, here minus 5 and modulus of minus 5, 5 it will become. So 5 by minus 5, what value I will get, my dear students? I will get minus 1. So these are the range, my dear students, and my domain is entire R. So I have taken every R, but my value is only 1, 0, minus 1. That's all, my dear students. So my graph is also looks like here 0, 1, minus 1. So my dear students, for R plus, it goes like this, 0 like this, my dear students. So minus 1, it goes like this. Okay, my dear students, this is how the graph will be. I hope you understood it well, my dear students. Now let's move on. So now y is equals to signum of x. For this, we are going to do entire research, my dear students, and this is the graph. That's what they also have given. So what is the domain, my dear students? Already we have discussed. The domain is R. What is the range, my dear students? Range is minus 1, 0, 1. That's all, my dear students. Only the 3 elements is there in range. Then symmetric about. These two are like very important in signum function. Sometimes they ask you to confuse you. Symmetric function. Signum of symmetric about what? They'll ask, my dear students, which is symmetric about opposite quadrants. Don't confuse yourself, my dear students. Symmetric about opposite quadrants. Okay, my dear students, I hope you understood, because here it goes like this, here it goes like this. So if I hide some part, then you can see the same reflection over here. If the reflection is over here, then we can say that thing as the symmetricity, my dear students. Already we have seen so many graphs in polynomial function. Almost for every graph we had this symmetricity, but here bit it is confusing because this one is the discontinuous function. Though it is discontinuous, it is symmetric about opposite quadrants, my dear students. That thing you have to keep in mind. Okay, now symmetric about opposite quadrants, my dear students. Then if it is symmetric about opposite quadrants, what, my dear students? That function is an odd function, my dear students. That function is not an even function. Even function means symmetric about y-axis. If it is symmetric about y-axis, then that function is an even function. If it is symmetric about opposite quadrants, then that function is an odd function. That's all, my dear students. I hope you understood it. For odd function, you might have the doubt. How, sir? Here only we are getting 1 minus 1, the constant values. But how you are saying it is an odd function? Let me explain you, my dear students. F of minus x equals to minus f of x, my dear students. So this is the definition for odd function. Here you have to note one very important thing, my dear students. What is that means? So if I take in that function any values of negative, my entire function have to change. My entire function's values are changing into the another sign, another symbol. So if it changes like that, only then that function is called an odd function. For me, the values doesn't matter whether it gives positive, whatever values. For me, values, it doesn't matter, my dear students, but sign matters a lot. So here in place of f of minus x, if I am replacing, my dear students, signum of minus x means I am getting the minus x. Minus x means what, my dear students? My x belongs to or negative. If it is or negative, what the signum function will give, my dear students? Minus 1. For entire negative side of signum function, it gives me only the minus 1 value. So here you can see f of minus x minus of f of x, minus of 1. So minus of 1 means what, my dear students? My function's value, my function have that sign changeover, my dear students. Okay, so this function is an odd function. I hope you understood it well, my dear students. If you have any kind of doubt, please ask me in the comment section. I'll upload separate video, or I'll send you the solution. I'll contact you, my dear students. Okay, so that it is an odd function, my dear students. Periodic, strictly no, my dear students. One to one, no, my dear students, because we used to find with horizontal line. Here the function is there itself in horizontal line, so it won't be there, my dear students. Why? Because for plenty of values, it is taking the single value as the answer. So it is completely against to one law. So that this function is called as many to one, my dear students, not one to one function. As well as this one is not onto function, my dear students. For most of the things it is onto only. Maybe if my codomain has only these three values, -1, 0, 1, only these three values, then that function is an onto function. That also only these three, my dear students. If maybe some other value is there, like 2 is there, 3 is there, means no, then that function is not the onto function. If these three values are only there, then that function is an onto function, my dear students. Then bijective, no, my dear students. Whether onto comes or not, it is strictly not a one-to-one function, so that it is not bijective function, my dear students. And this is increasing as well as decreasing, my dear students. Derivative, derivative here means, here it is the what, my dear students? It is the discontinuous graph, my dear students. So the graph is not differentiable everywhere, differentiable somewhere. You have to find what is that somewhere, my dear students. So, okay, I hope you understood it well, my dear students. That's all. I have said everything. If you have still you have to know, still you have to learn anything new, please comment it down, my dear students. Okay. So this is what they also have given, my dear students, the definition. Apart from definition, we have seen so many things. I hope you enjoyed this video. If you enjoyed, please comment it down, my dear students. Or if you find any mistake or any doubt is there, please comment it down. Whatever, my dear students, whatever you are feeling, please comment it down. Then only I can understand in what way I am going, how to change my teaching ways. Like that I can judge myself, my dear students. Okay, my dear students, bye bye. Thank you, my dear students.